So I'd like to welcome all of you to session 2 in module 4. Okay. So in the last session we had a brief introduction of module 4. We understood the complete overview of module 4 in terms of testing and evolution. So module 4 is completely dealing with software testing and software evolution. So what is software testing, what is software evolution? So we had an abstract view of it, and we had started with different topics in software testing. Okay. So we understood software testing is trying to identify errors, flaws, bugs, issues with the software. Okay. Now the question is, when exactly you will try to identify those flaws, issues? So the answer to this question is, so you can try to identify the errors or issues during development when the software product is being designed and coded. Okay. So you can test for errors or bugs after the product is complete, which we call as release testing. Once the product is complete, the product will be given to the client, and client will start using it. So once the client starts using it, he may experience some issues. He may identify few flaws in the system. Okay. So that we call it as user testing. So in a nutshell, so software testing can be done during development, after the product is released, and when the client starts using the product. Okay. So these were the different stages of software testing that was discussed in the previous session, that is in session 1. Next, we took up development testing, and we saw a few more aspects of development testing. The different levels in which we could do development testing. So that was the topic of discussion. And we understood development testing can be done at the smallest level, smallest unit of a software component, which we call as unit testing. So units, smaller units combined together will become a component. Okay. So like that you can have multiple components in a software. So we can test the working of one single component, or maybe interaction between different components or a set of components, which we call as component testing. And the last one is, you will be integrating all the components and trying to test the system as a whole. Okay. So that is what we call as system testing. So these are three levels in which you can do development testing, and we understood we can start from the lowest level in the software design or component, and go up to the highest level. So bottom to the top. So this is what we had explored in the previous session. So we understood what are the goals of software testing. We also understood the different stages of software testing. So 3 stages are there, and among those 3 stages we had taken the very first one, that is development testing. So we explored the different levels in which development testing could be done. Okay. So we will continue from this point. So we will take up the very first one, unit testing, and we will see what is unit testing and few aspects of unit testing. So unit testing was briefed in the previous session. So unit testing is testing the smallest component, smallest unit in a software product. Okay. So the point here is, who will be doing the unit testing part? So that also we had explored. Unit testing may be done by the programmer who is writing the code. Unit testing may be done by a tester with the programmer. Unit testing may be done by a separate team who is part of the coding team, okay, who is with the coding team, involving themselves with respect to the product. So these are the different possibilities that exist with respect to unit testing. So it was explored in the previous session, so we saw that. So to continue with, so we will take up unit testing. Now how exactly unit testing is done, where it is done. Okay, so as discussed, it can be at the class level. You can even test the object. Okay. So you can test a class, you can test an object, you can test the behavior. You will be testing whether the specific object that is being generated is working as per the expectation. You will test the behavior of the object, the behavior of the class, okay, is working as per the expectation. Okay. So now the question is, how exactly unit testing will be done by the testers. Okay. So one basic aspect here is testing will be basically done by writing test cases. So what will be there in a test case? So test case will contain a test ID, because we can have hundreds of test cases. Okay. What is the typical input that you are giving to the system? Okay. So what is the process that will happen? What is the output that you will be getting, and what is the expected output? Okay. So expected output. Now it goes without saying that the output that is obtained because of a test case and the expected output should match. Okay. And in that case you declare the test case to be pass. Okay. So meaning that if the output that you get because of a test case is matching with the expected output, so the test case is declared to be a pass, else it is a fail. Okay. So all this stuff will be arranged and that forms a test case. So like this you can have hundreds of test cases written to test a product, software product. So a collection of test cases, typically it is called as a test suite. So the details of which we will see later. Okay. Now how testing will be done? What are the different possibilities that exist here? Okay. Basically testing can be manual testing, so where an employee, human being, will be writing the test cases, will be executing the test cases, and he will be comparing the output that has been obtained with the desired output. Okay. So it's a completely manual process, it's a tedious process, time consuming process. Okay. So to overcome it, we have automated testing. So automated testing. What exactly happens in automated testing? What are the different stages, different parts in automated testing? So we will just explore it. So the third part is regarding automated testing. So automated testing has three parts. The first one is the setup part. So in the setup part, so you will decide on the inputs that you will be giving to the system. So as already mentioned, basically these are the primary requirements of a test case. Okay. So what is the input you are giving? Okay. So what are the initializations you are doing? So what are the initializations? What are the inputs you are giving? What is the process that is typically expected in terms of execution? Okay. And what is the expected output? Okay. So this is the setup part where you are feeding the tool with input, initialization, process and output. And also for information, the tool itself can initialize itself. The tool itself can generate typical inputs and expected output. So automated testing tools are capable of doing this. Okay. Now this is the first part in automated testing, that is the setup part. The second part is the call part. So in call part, the required routine, the required object that needs to be tested will be called, and it will be given with that specific input. Okay. For example, we want to test a class or an object as part of unit testing. Okay. So this object will be given with the required input. For example, we will assume we have an object as part of a registration form. So this is a registration form. This registration form, we will treat it as an object now, just for the purpose of understanding. This registration form is taking username and password as input. Okay. Now trying to correlate it with this example, Now in the setup part, so the testing tool will decide what is the input, what are the initializations that should be given to the registration form. So in this example, it is username and password. Okay. Now what is the typical output? So typical expected output is the registration should be successful for the given username and password. Okay. So these things are initiated in the setup part. Now what is call part? What exactly happens during the call part? So the object related to this registration form, so there will be an object associated with this registration form. So this object will be initiated, meaning that the registration form is being initiated. Okay. And the input will be given, meaning that a sample username and password will be given to the registration form. Okay. So that was the second part, that is the call part. Now what is the third part? So third part is what we call as the assertion part. So assertion part. Now what happens in assertion part? So assertion means, in this context, it is comparing what output was obtained with the expected output. Now in this typical scenario, what is the output that is being expected? So a registration form object has been invoked. We are trying to register a user with username, password, mobile number and other stuff, all of which were initiated during the setup part. Okay. Our typical expectation is, once these details are provided, okay, so the registration should be successful. The registration should be successful, and this data should be stored in the database. It should be stored in the database. So this is expected output, expected scenario. Okay. And if for the sample input that was decided upon in the setup part, this happens, meaning that the user successfully registers and his details are stored in the database. If this is successfully done, then we call as the test case to be successful. That is expected output. This is what we were expecting. Okay, registration to be successful and all the registration details to be stored in the database. This is what we were expecting, and if we achieve it, then the assertion is true. Okay, that is, it is successful. If it does not happen, for example, for this given input registration, there is some issue with the registration. Okay, it is giving some errors. Okay, it is behaving in an unexpected way. Okay, the registration form is taking the data, but it is not storing in the database. See, these are the issues that we may experience during testing. Okay, so if any of these issues occur, then the assertion fails. Okay, meaning that the test case has failed. Okay, so this was automated testing. So the summary here is, in unit testing, which is the lowest level in development testing, okay, we test the smallest parts, smallest units in a software product. Okay, it can be a class, it can be an object, it can be a small function, it can be a routine. Okay, the smallest component, smallest part. So that will be tested. How typically testing will be done? So testing will be done using test cases. Test cases will be written. Now what is there in a test case? So test case typically consists of test case ID, because you can have hundreds of test cases. Test case ID will be there, followed by the inputs that should be given as part of unit testing. What initializations needs to be done, all the details will be given. So what is the process that should take place? What is the output that is expected to be obtained? Okay, so all this stuff will be specified in a test case. Okay, so we also understood testing can be done manually. Okay, testing can happen in an automated way. So manual testing is labor intensive, okay, time consuming. Instead, we can use automated tools which will do the task within less time. Okay. We also understood how exactly automated testing is done. Okay, so it is done in three parts. The very first one being the setup part, where we decide upon what are the inputs that should be given to the system to test the system, to test the small unit. Okay, what initializations needs to be done, what is the process that should be followed, and what is the expected output. So all this data will be decided in the setup part. The call part will typically call the object or class or the smallest unit that needs to be tested. Okay, the call part will result in an outcome. Okay, and if that outcome is matching with the expected outcome, we claim that the assertion is true, and that is the third part. Third part is like the results, pass or fail. Okay, so that was all about automated testing. So in unit testing, we can also use one more idea here called as mock object. So what is a mock object? We'll try to understand. A mock object mock object is typically a simulated object for feeding input to the object or class or the unit that is being tested. Okay. For example, we will assume we have built a small unit, a small sensor unit, which is taking inputs after every 30 minutes. Okay, after every 30 minutes. So this small unit, okay, is taking input from the external environment. It is reading the input. But the constraint here is after 30 minutes. Okay. Now I want to test this unit. I want to test this part of the software. Now can I wait and try to obtain the inputs after every 30 minutes? Okay. Once again, it is time consuming. I need to wait for every 30 minutes and I need to determine what is the input that is coming, then test whether this unit, this part is working correctly. Instead, what I can do, I can create a mock object. Okay, for example, typically if the input is coming at 10 AM, so as per this design, okay, so at 10 AM some input is coming to this system. Okay, for example, we'll claim some value is coming 35 at 10 AM. Okay, at 10:30 AM, okay, one more input is coming 45. Okay, so please note we are waiting for this duration, okay, just to test the behavior of this unit, just to check whether this unit is working properly. So instead, what we can do, we can create a mock object here. Okay, so we can create a mock object. It's a dummy object, as the name itself is indicating, which will provide the same input. Okay, same input. So we need not wait for that duration. So it will save our time. This was a typical example. So the key idea here is we will create dummy objects which will feed typical inputs during unit testing. So we need not wait for the actual inputs. We need not wait for the actual events to occur. We need not wait for the actual triggers to happen. Instead, we can do the same using dummy objects or simulated objects called as mock object. Okay. So this will help us perform the testing in a more effective way. Okay. So within less time. Okay. Now the next question is choosing unit test cases. So as previously mentioned, the basic aspect in unit testing is you need to write test cases. Okay, test cases should be there where you specify what is the input, okay, what are the configurations, what are the initializations, what process should happen, and what is the typical output that should be obtained from this unit, from this routine in the software, okay, or from this part of the software, from this interface of the software. Okay. So test case will have a predefined template with all the data here. Now the question is, can I test everything? can I write test cases for all possibilities? Can I do it? So the obvious answer for this question is no, definitely not. See, you cannot test each and every aspect of the small unit that is under consideration. Okay. Now, what is the answer for this? What is the solution? If we cannot test for all possibilities, if you have a unit, okay, you have a small unit. As I mentioned, this unit may be a small routine, a for loop itself, a while loop, okay, or one small part of the program, or one program itself, or an interface to the program. Okay. As I mentioned, I cannot give all possible inputs. Okay. I cannot give all possible inputs. I cannot consider all possible inputs to be part of the test case and check whether this unit is working as per the expectation. It is not possible. Okay. It cannot be exhaustive. You cannot do it because of various reasons, which include time, resources. Okay. So time and resources are crucial components here. So you cannot, even if you are using an automated tool, so it will be time consuming. So if you are checking that specific unit, that specific part for all possible inputs. Now the solution to this situation is, in order to do the testing but without considering all possibilities, so we need to come out with some strategy. Okay. So what is that strategy? What are the strategies for choosing a test case so that we do not go with all possibilities, all inputs? Okay. So there are typically few strategies suggested, okay, and we will just explore it. One strategy is, so this is strategies for test cases. So just now we understood you cannot write all possibilities as part of a test case. You cannot check everything. Okay. Now what are the possibilities? What are the strategies you can incorporate? One is partition. Okay. So partition testing. So it is similar to choosing a sample. Okay. So choosing a sample from data which are common. Okay. I'll give you examples of it in the next instance where we will discuss equivalence partitioning. So next topic of discussion is equivalence partitioning, where we will understand how exactly partitioning can be done based on the common characteristics of the data. Okay. So instead of selecting everything, we will just select some samples which are representative of the entire population. Okay. And we will try to write test cases. The second strategy for writing the test cases to avoid coming out with all possible inputs, to avoid writing all possible test cases, is what we call as guideline based. So guideline based testing. So what is guidelines based? So this is based on the previous experience, okay, of designing, developing and testing a software product. Okay. I'll give a typical example. Consider a software company is sufficiently experienced with developing a hospital management software, meaning that previously it has the experience of designing such a software, implementing such a software, and during that design and implementation part, now it has experience of where things may go wrong, okay, where errors may occur, where flaws may generate. Okay, so based on experience, it will have insights of in which part of the software errors may occur. Okay. Now, those parts of the software, okay, will be rigorously tested, and please note this was decided based on the previous experience. Okay, so that is the reason it is called as guideline based. Okay, so we had some previous guidelines based on our past experiences, using which we decided which parts or which units to be tested and what type of inputs to be used to test that specific unit. Okay, so that was guideline based. So in a nutshell, we understood unit testing, which is the lowest level, the lowest possibility in development testing, which is one of the stages in software testing. Okay, so can be done or should be done by writing test cases. You should write test cases where you will specify what is the input, okay, how the data or the input should be processed, and what is the expected output. Okay, and if everything goes fine, meaning that the output that we obtained for that input and the expected output, if both are same, if x equal to y, okay, so it means that the test case is successful. So we understood testing can be manual or even it can be automated. Okay. So we also understood test cases cannot be exhaustive. You cannot come out with all possibilities, okay, to test a system. There are reasons to it because of times and resources. So even if you are doing automated testing, so the solution is we will come out with few strategies which will help us select test cases which yields optimal results. Okay. So now what are the strategies? So two typical strategies were discussed. One is partition testing, where we try to select representative samples from the data and it will be used to test the unit. Okay. Guideline based, where we will utilize our previous experience with the product. Okay, we will try to identify parts of the system which typically generate errors or flaws. We will typically identify the type of inputs for which the system will generate errors or flaws, and we will try to test our system so based on that criteria. So that was guidelines based testing. Okay. Now we will try to shed more light on partition testing using the concept of equivalence partitioning in software testing. So the next topic under discussion is equivalence testing, or equivalence partitioning. So as I already mentioned, we cannot consider all possible inputs to check whether the unit or the part of the software is working correctly. Okay, so definitely we need to have some samples. So how exactly it is done? So we will see in equivalence partitioning for software testing. Okay, so I'll take a typical example which will give clarity with respect to what exactly is equivalence partitioning. Okay. Now assume I have a program, a small unit as explained. Okay, this program will take a number. For example, if I enter 1, okay, so this program will give me the corresponding month, which is the numerical equivalent. For example, if I enter 1, maybe it will give Jan. If I enter 2, it will give me Feb. Okay, we'll just take this small simple example just to understand what is equivalence partitioning. Now, in order to check the behavior of this program, I need to write test cases. It was already informed. Okay. Now, what are the range of inputs? What are the different possibilities here with respect to giving the inputs? So just you can see. So starting from 1, it will go up to 12, meaning that I need to write 12 test cases here. Okay. This was for valid inputs. What if someone enters something unexpected, like someone enters 50? Okay, it is an invalid input. Someone enters -1, it is also invalid input. Now in this case, what is the behavior of the program that should be checked? Okay, even if unexpected inputs are given, the behavior of the program should be consistent. Okay, now is it so? That is what we are checking. So you can see here we have different possibilities. One is all possible inputs which are valid. So we will call it as a valid partition. Okay. So for my program, for my example program, numbers 1 to 12 is valid. So this program can take this input and give the desired output. So if you are entering 1, it will give Jan. If you are entering 12, it will give December. That is what is expected. Okay. Now this is valid. Also, we understood a user may not always enter a valid input. Okay. Some unexpected input may be given. Okay. In this case, you are seeing he may enter -1. Okay. He may give a 0. He may give -2. Okay. This is an invalid partition. So possibilities which are invalid. So we call it as invalid partition. Here you can observe the user is going into the negative range, 0 and negative. So I will call it as invalid partition 1. Okay. Next, one more possibility. The boundary here is 12. Okay, user may go beyond this, meaning that 13, 14, he may enter 13, 14, 15, 100, 200, may go up to any value. I will call it as invalid partition 2. Now what is invalid partition 2 in this context, in this example? Invalid partition 2 is the range above the maximum. Okay. Invalid partition 1 is the range below the minimum. So this will be called as invalid partition 2. So invalid partition 1 and invalid partition 2. Okay. Now what is equivalence partitioning? Okay. What exactly happens during equivalence partitioning? You can see these are the possible inputs that can be given. Okay. So it can be negative in range, it can be valid input in the range of 1 to 12. Also it can be invalid input from 13 to n. Okay. So what we do here is we classify. Okay. We classify the input range into valid and invalid. Okay. Also we represent it graphically also. So we do it with a graphical representation. I'll just illustrate it here. Okay. So if this is all possible inputs, okay, if this oval is indicating all possible inputs, okay, so this is all possible inputs, okay, so the small portion inside, okay, so this will be called as valid input. Valid input, in my example it is months 1 to 12. So months 1 to 12 will be treated as valid input, and the remaining stuff that you are seeing outside this circle, okay, so whatever you are seeing outside this circle, it will be treated as invalid input. So this is a graphical illustration of equivalence partitioning. You can see the division is there. Okay, so we have divided it. Okay, fine. Now, so we have different portions here. Which portion of the input to take? That is the big question now. Now, shall I take 1, 2, 3, 4, 5, 6? Shall I take 9, 10, 11, 12? Which one to take? So, as already discussed, I cannot consider all inputs. I cannot go with all the inputs. It may be in a valid partition or an invalid partition. I cannot go with all the inputs. Now, what is the solution for this? The solution is what we call as boundary value analysis. Okay, so what is boundary value analysis? So, typically errors occur near the boundary values, and those values are selected for testing. Those values are used in test cases. For example, now consider the valid partition. Now what are the boundary values of a valid partition in this example? Okay, so boundary values are 1, which is the minimum, 12, which is the maximum. Please note 1 and 12 are at the two extremes, so they are the two boundaries, and also mid will be taken into consideration. So what is the middle range between 1 and 12? It is 6. Okay, so typically in equivalence partitioning, where we try to identify valid and invalid partitions, boundary values will be selected for writing the test cases. Okay, so we will not be selecting all the numbers 1 to 12. Okay, so in my example, so we will test this program with 1, we will give 1, so you should get Jan. We will give 6, so you should get June, and you will be giving 12, so you should get December. So this is what we call as boundary value analysis. Okay, typically we try to take data which is in the boundary region. Okay, because as per observations, it was found that errors or flaws are generated for boundary values. Okay, the same is applicable even to invalid partitions. Typically in the boundary region, the values are handpicked, so it will be taken. Okay, so this was all about equivalence partitioning with boundary value analysis. The next concept under unit testing is black box and white box testing. We will try to understand what is black box and what is white box testing. Okay. So what is black box? See, black box is basically functionality. Okay. Basically, it is more concerned about functionality of that particular unit, component or system. It is not worrying about what is there inside. Okay, what the inner details, or to be more specific, the coding details of that unit. Okay, so that will not be taken into consideration by the black box. So black box is just treating the unit, okay, as one single part without taking in consideration what is there inside. Okay, what code is there inside. So that will not be of any concern during black box testing. Now how it will be tested? So I will take the same example that I had utilized. So the program, which is taking numericals, numbers, and printing the corresponding months in string. Okay, so I will enter 1, Jan is to be printed here. I am entering 6, okay, June to be printed. That's it. That is what you are testing as part of black box testing. Here we are not concerned about what code is there inside, what routines are executing. Okay, we are not worried about it. Only thing we are worried is this input being taken by the unit, okay, and is it giving the output that is desired. Okay, that's it. That is black box. Now what is white box testing? Okay, so in white box testing, we go into the finer details of what is there inside the unit, and we design the test cases. Okay. For example, if you are carrying the same to white box testing, how things may be different. We will try to explore. Okay. Now this is a program. We understood what program it is. This is a program which is taking a number and printing its corresponding month equivalent. Okay. When we enter into the program, we understood there are two for loops. For loop 1 to 6. I will not write the exact syntax. Okay. Okay. And one more for loop is there. 7 to 12. Now, when I saw into the finer details of the program, when I analyzed the code of the program, I understood two for loops are there. One for loop, or the first for loop is handling months 1 to 6. The second for loop is handling 7 to 12. Okay. Now, when I am planning with the test cases, what I should do? So I need to ensure that both the for loops are tested. Both the for loops are tested with typical inputs. So how I ensure it? Okay. So you can see the first for loop is executing in the range 1 to 6. So I will select a sample from it. For example, I may select 1, 3, 6. Okay. Second for loop is executing 7 to 12. Maybe I may take 8, 10. Now what I am ensuring here? The first thing is I am not doing a exhaustive testing where everything is tested, each and every iteration of the for loop. For I is equal to 1, for I is equal to 2, 3, 4, 5, 6. I am not doing it. I am selective. Okay, definitely I am selective with respect to the inputs. But what I have done here, I have gone into the details of the program. I have seen the coding part of the program, and after analyzing the code, I have decided on the test cases. In this specific example, you can see I understood there are two for loops. Okay, I made up my mind that both the for loops should be tested, and for my test case, I have selected these inputs 1, 3, 6, 8, 10. Okay. Now, while writing the test cases, I can ensure both the for loops are tested. Now, how this was possible? This was possible because I went into the coding part of the program, and then I designed the test case, because of which I could ensure all the important routines in the program are tested for possible inputs. Okay. Now the same with respect to black box. What may happen in a black box? Okay. For example, I do not know what is there inside. I am not bothered about the coding aspect. Fine. I may choose a number 1, 5. We'll assume like this. Okay. Now anyhow, the number 1 will be given. Which for loop will execute? The first one. The first for loop will execute. I gave the number 5. The first for loop will execute. Now I finished with my testing. I finished with my test cases. Now what is the problem here? What is the issue? The issue is my second for loop that was there, so was never tested for any inputs. Okay. So that is the drawback with black box testing. So it depends on the situation and scenario. So components, parts or units of a program which are very crucial. So typically Whitebox testing is suggested. So you can go with Blackbox for the remaining part. Okay, so this was one more aspect in unit testing, the Blackbox versus the Whitebox. So this was the first level, the innermost level, the basic level in development testing. Okay, so called as unit testing. We understood unit is the smallest part, the smallest piece of code, the smallest routine, a small interface, okay, which needs to be tested. What exactly you are doing in testing? You are trying to check whether it's working as per the expectation, okay, without any issues or flaws. Now we understood different aspects of unit testing, starting with the importance of test cases. We also understood you cannot write all possible test cases. You need to be selective, and while being selective, you need to be careful. Okay, and to be careful, we understood what are the strategies we need to adopt. Okay, also we understood the significance of equivalence testing, boundary analysis, boundary value analysis, and black box one, white box testing. So the next type of development testing is component testing. Okay, so we will see what is a component testing. So previous discussion was related to units, the smallest part. Okay, what is a component? Okay, maybe small units integrated together may become a component. For example, I have some small units, unit 1, Unit 2, Unit 3, three units integrated together may become one component. I'll call it as component 1. Please note, we are moving from the bottommost level, that is the smallest unit, to the next level in the hierarchy. So it's a bottom to top approach. Okay. So in unit testing, we tested the lowest part, the smallest part, and as we progress to component testing, we are moving above the hierarchy, so from bottom to top. So small units will be combined, which becomes a component. Okay. And we can have n number of components like this: component 1, component 2, so component 3. So we can have many components like this. Okay. Now what exactly will be done in component testing? Now the basic emphasis in component testing is we will be checking whether a specific component is interacting correctly with a different component. For example, I have component 1 and component 2. Okay. So whether component 1 is communicating correctly as per the expectation with component 2, and vice versa, component 2 communicating correctly with component 1. Now the derivative here is basically what you need to do is you need to test the interface between the component. So as you can see in this graphical illustration, the lines that you are seeing between the components are the interfaces. Okay. So they are the interfaces here. Interfaces are typically communication points between the components. For example, if component 1 wants to send a data to component 2, okay. For example, it wants to send something x equal to 3 to component 2. So it will use this interface. I'll call it as interface 1. I'll mark it as I1. So I1 will be used and it will send the value x equal to 3. Okay. Component 2 want to send something to component 1. For example, it wants to send y equal to 4. Okay. So it will use this interface 2. So basically in component testing, we will be checking whether the interfaces between the components, which is used for communication, is working correctly. Okay, it is working as per the expectation. So all these things will be dealt with. So this was about component testing. In the next session, we will go into the details of component testing. We will see the different types of component testing, issues we may experience with component testing, and how to resolve it. Okay. And basically, as you saw, interface is a crucial component here. We will study different aspects of interfaces. Okay. So to conclude with, so in session 2, we understood unit testing, okay, the different aspects of unit testing, the importance of test cases, the strategies you need to follow when you are writing a test case, the significance of equivalence partitioning, okay, boundary value analysis, white box versus black box testing. So all these things were covered in this specific session, and a brief introduction to component testing was given. So thank you.